All right. Once you get all that down in your notes, then we'll talk about it, work some problems about what it means, and we still have a little bit more to add to that as well. I mean, does that help? I zoomed in a little bit. Does that help you? It's gross.
Are you gonna go all out tomorrow for the red out?
Are you?
I got a red shirt.
Yeah. I don't have anything
I got a red shirt,
except
yeah.
for my volleyball shirt. And my volleyball shirt swallows me.
And it's black.
Go buy like a popular red shirt.
Yeah, I'm good.
I'm not even talking to you. Shut up. To go buy me something for me today.
So, sometimes at Dollar General they have Harmony Grove shirts.
Let's go to school shop.
You wear a red bodysuit.
Oh yeah, if I was working, yeah.
What
I'm not
kind
bothered
of
with
one?
it.
That's all yours for your ring.
I'm trying to get my school experience again, so I'm about to go all out tomorrow.
Black and gray.
Are we close? Are we getting close?
Not really.
I'm horizontal.
I'm
Okay.
still doing the graphs.
All right, come on.
Trevor won't quit talking. They're not even talking. I'm right. I got one of
Don't you have a new house or newer? Did you move? Like not like. Oh, y'all moved in with Brandy?
Yeah, a long time ago.
I didn't know if y'all had gotten a new house or if y'all moved in with her. I just knew y'all weren't living by that church.
Y'all good? Everybody good?
No, I'm not good yet. I have
Quit
one
talking
more-
to Trevor. Come on.
One more graph.
Oh my gosh, I know. I could drag this. It was raining so much. Or what is it right before we switched classes?
Where's that one?
Where is it? They started sprinkling when I was about to pull. Or no, when I left my house, they started sprinkling. But then when I was going to the school, because I had no idea.
I'm done.
Oh, yeah. I do that every day. I ain't gonna freeze up at all the whole way to school. You know, like, the worst So did it's like either
Yeah.
I'm gonna fall asleep to it or I'm
You
gonna
be
go
replacing
to
everything.
like, which one do I want?
You do what? You be replacing everything. The truck was new, turnovers.
You got it, Trevor?
Yeah.
Everybody good? All right. We're gonna add some notes to that and talk about what all that stuff means and how we're gonna use this. We got a lot of stuff to get done. Everybody ready? Ready? All right, a little bit of background. I need to give my piece of graph paper to use. A little bit of background. Trevor, y'all listen. A little bit of background on what we got going here. I could have a parabola, something like that. Okay, that's pretty good there. Pretty wide.
We need to start drawing this. Is that what we had done?
It's similar to what you have down, yes. I gotta have a parabola here, and what we're dealing with, we're gonna hear new words today called the focus and the directrix. E-C-T-R-I-X. Okay, the focus is always going to be on the inside of the parabola. It's going to be on the axis of symmetry, and it's going to be equidistant from the directrix. So what that means here is this vertex will be halfway between the directrix and the focus. So my focus on this is just a point. My focus would be here, and my directrix is actually going to be this time on the axis. So I'm going to highlight it so you can see it. that would be my directrix. Okay, so what we've got, this is our focus, this is our directrix. Okay, and then we know right now the y-axis would be the axis of symmetry on this particular graph, wouldn't it? Remember that? Alright, so the focus and the directrix have got some special relationships that we're going to be able to look at, and it's going to involve using the distance formula a little bit. So if I said that this point, if I count on reds, it'll work. This point is at 0, 2. My directrix actually needs to be down one, doesn't it? I didn't draw that very good. If that point's at 0, 2, my directrix here would be because the parabola, it's half. So that's 1, 2. No, I did it right. Because that's one above and that's one below. I had it right. Y'all, I second guessed myself. I'm sorry. Trevor's first period class still has me rattled.
Why? What did we do wrong?
I didn't do anything wrong. They just got me rattled. Alright, so I had it right there. Okay, so what we're dealing with, that is equidistant. Okay, from the focus to any point on the parabola, from that same point to the directrix, that's equal distance. So mark them the same way, put 1 mark or 3 marks, whatever, so that we can use the distance formula to set these equal to each other. Okay? So this point here, now that could be named whatever. How many do I go over to get there? It could be named whatever x and then whatever y, just like normal. So we're going to plug some x and y's in. I want to just go ahead. This is I want to go ahead and give you a problem. Can we try? Because this is not going to make sense if we just keep drawing stuff. You're going to see it better out of a real problem. So let's go ahead and look at, I've got a focus of 0, 2 and a directrix of y equals -2. Okay, so this is all that's given to us. We've got a parabola that has a focus of 0, 2 and a directrix of y equals -2. The directions say use the distance formula to write the equation of the parabola. Okay, so we remember our distance formula.
That y equals
Say that again.
it's not y equals b.
No, that's slope-intercept form. Our distance is going to be equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Now what we're going to do with that, though, is going to be a little bit different, because like we had over here on this previous page, we're going to be setting two distances equal to each other. So I'm going to have a distance formula equal to another distance formula. So we're going to set this up as, we're going to take out some of those x1s and we're going to have actual variables in it. We're going to have the square root of x minus x1 squared plus y minus y1 squared. That's going to be one section, is equal to, now we're distance formula over here, we're going to have to use our 2's in this one. X minus x2 squared plus y minus y2 squared. So what we got to figure out is how to label our stuff that we have up there so we'll know some ordered pair to use. We've got one plain as day point in that focus, 0, 2. So I went ahead and if I've got 0, 2 here, that could be your x1 and y1, right? Okay, now we got to use this y equals -2 to get our other point. If y equals -2, what's x? Now remember, you don't have to draw this, but y equals -2, you would go down 2, it would be a horizontal line through -2, right? So you can have any x you want and still be y equals -2. So your ordered pair for y equals -2 is going to be some variable -2. Okay, so there's my x2 and my y2. Okay, so in this big looks big and scary equation that we have written here, anywhere it's got an x or a y without a subscript, you're going to leave that xy. X1s get replaced, Y1s get replaced, X2s get replaced, Y2s get replaced. Okay, so we're going to say square root of x minus 0, because my x1 is 0, right? Squared plus y minus, started right, -2. Y minus 2, my y1 is 2, squared. Equals, now this side we're using our other x and our y, so square root of x minus x2. My x2 is x again, isn't it? See that? Right? Following? Plus y minus y2 is -2. Where at? Right here, right here.
So
Y minus -2 squared. Alright, so now we're going to see if any of this stuff can be simplified, and some of it can, because right here, you got x minus 0. X minus 0 is just x, so that'll be x squared, right?
Right.
Okay. Now, on the y minus 2 squared, that means you take y minus 2, you write it twice, and you FOIL it, right? Okay, can you do that real quick? Let me get a dry erase so I'm not writing, because we're going to need a lot of room. I'm right here, I'm looking at y minus 2 squared. Y minus 2 squared means I have y minus 2 times y minus 2, right? So you got y squared minus 2y minus 2y plus 4. So that's y squared minus 4y plus 4. Okay, so now we've got x squared, and then we're going to put all of that we just did, x squared plus y squared minus 4y plus 4. That's still all underneath that radical. Okay, no more like terms underneath there, so I'm coming over here to the left side. I can simplify this because x minus x is nothing, right? 0 squared is nothing, so that's away. But now this minus and negative underneath there is the same as y plus 2, isn't it? So we have y plus 2 squared. So again, we have to take y plus 2 twice. Y squared plus 2y plus 2y plus 4. Combine those like terms. Y squared plus 4y plus 4. So that's what we got under our radical on the right side. Alright, now we're trying to solve this and actually get a parabola equation. And those, all the parabolas that we've done since we've changed to quadratics have been y equals something x squared. So we want to end up getting our y's on the same side and our x's on the same side. But nowhere in any of the parabola equations that we've messed with so far did we have any square root signs, any radicals. So I want to be able to get rid of that. The good thing is I can just cancel them out. Because if this whole side's being square rooted and this whole side's being square rooted, I can undo that by squaring the whole thing, and the square and the square root just cancels out. Right? It's like square root of 4 is 2, 2 squared is 4. It just cancels each other out. So now we're just going to square that whole thing and cancel out those radicals, so all we've got left is x squared plus y squared minus 4y plus 4 equals y squared plus 4y plus y. Alright, remember y equals x squared would be a quadratic. So we want to start moving stuff, x's towards the same side and y's towards the same side. Good stuff's going to happen here. Like, check this y squared out. If I wanted to move this y squared over, I would subtract it from itself, and it's like term. What happens to both of those y squares? Good. Y squared minus y squared is nothing, like Connor said, and y squared minus y squared is nothing. So that canceled out. Yes, Kristen?
It is a 4.
Yes, it is supposed to be a 4. Thanks, sweetie. They messed us all up.
Oh, I thought you were good.
Good, good. Kristen caught my mistake there. That last one was a 4. Okay, good. So that's going to be good, because now let's look at that 4 since Kristen found that. If I subtracted, y'all pay attention, if I subtracted 4 from itself and from its buddy, those 4's just canceled out, didn't they? So we're looking now at x squared minus 4y equals 4y. Okay, we said we're trying to get the x's on one side and the y's on one side. So what would be a good move here to try to do that? That's good, good, good. I got it, Lena? X squared equals 8y. We're almost to a parabola. Parabola's apparent function is y equals x squared, so we need to solve this for y. It's going to be multiplied by 8.
Divide by 8.
Divide by 8. So our parabola would be named y equals x squared divided by 8. Isn't that the same as 1/8 x squared? That's it.
That's a lot.
That's
It
a lot
was.
for one problem.
He
should have
started.
started.
Yeah.
I feel like we're addicting something.
Feel like we're inventing something, is that what you said?
Yeah.
Alright, want to do one more like that before we get into those notes you copied off the picture. So, we're still not to those yet. I want to do one more like that. Everybody got what you need on that one? Okay, this time,
You throw me off. Your 4s and your Ys look the
Yeah.
same.
I know.
Yeah. So, way off.
Like up here on the board, you just look at it. Does it not look like a Y?
Yeah.
Then just listen to her. She says it out loud.
Yeah, but then you're behind
because you had to stop talking to Trevor.
I'm trying not to talk. I'm doing my best.
I can't keep up as you go fast.
Watch the YouTube video.
Because you take the time and talk to Trevor.
I'm still writing though.
There's a little bit more to it, Mr. Lena. Okay. Alright, same type of problem. This one we got a focus of 0, -3, and a directrix of y equals 3. Alright, here's how it started the last one. My point that I know everything of. That's going to be my x1 and my y1. Okay, I got to use this directrix to get another point, and I don't know the x because it could be anything. So my other point's going to be just an x and a 3. That's my x2 and my y2. So you're behind already because you're horsing around. Distance formula, I'm going to set this stuff equal to each other. I'm going to say the square root of x minus x1 squared plus y minus y1 squared is equal to square root of x minus x2 squared plus y minus y2 squared.
If we have a negative minus a negative, would it just be addition?
Yes,
But even in this, like, even when it's set up like with the y minus y1,
yes. Okay, so all we got to do now is go and substitute x1, 0, and everywhere there's an x1, -3, and everywhere there's y1, you're just substituting your stuff in. That's not hard, we can all do that, so it's going to give me, this is x minus 0 squared plus y minus -3 squared equals x, my x2 is x plus y minus 3. Okay, any questions on that? Got that plugged in pretty good. Now you're just looking to simplify any of it that you can. This is where you're going to have some stuff cancel out, and this is where you're going to have to do some multiplying like we did over there on the dry erase board. Okay, x minus 0 is just x, so that one will be x squared This is what Chloe was talking about. Minus -3 is the same as y plus 3. So you have to take, I'll do it in a different color up here at the top. You have to take y plus 3 twice.
Why do we have two -3s?
Because,
Only one.
but the formula says y, right? Is this the other one you're talking about?
Yeah.
It says y minus.
Oh, okay.
Yes. Alright, so I'm multiplying those two y plus 3's there. That gets us a y squared plus 3y and plus 3y is 6y. And then plus 9. Did you get all that, Landon?
I
So
did,
we
I got
X-
every bit of it.
X squared plus y squared plus 6y plus 9.
There we go.
There we go.
Over here, the x minus x is nothing, so that cancels. But then we got to take y minus 3 twice. So I'll do that over here in the blue. Y minus 3, y minus 3. It's this y squared. Negative 3y and negative 3y is negative 6y. And then plus 9. So that'd be the square root of y squared minus 6y plus 9. Okay, now you're looking underneath the radicals for anything else that you can simplify. Is there any more like terms under either one of the radicals?
There's a y. No, that's squared.
Good, good. So y'all are right. So there's not. So what you want to do now is get rid of the radicals. So you're going to undo those square roots by squaring everything. So it's just going to be x squared plus y squared plus 6y plus 9 is equal to y squared minus 6y plus 9. Okay.
Why do you square the 6y and the 9?
Because they don't need to
Squared
be.
everything.
Okay, good question. When I square this, all the squared does is cancels out the square root sign. The stuff underneath it will stay the same. Alright, so now we want our y stuff to be on one side and our x stuff to be on one side. Okay? What should I do? Tell me something to try.
9.
Okay, Chloe's subtracted 9 from itself and its buddy on the other side. That canceled both of those out. 9 minus 9 is nothing.
You know, 6y over there.
You can do the 6y.
Okay, which one do you want to do?
Left one.
The left.
So I'm going to subtract since it's being added.
Negative 12.
So that's gone. Over here, that leaves me with y squared minus 12y. Over here, I've got x squared plus y squared. What would make sense to do now?
The y squared.
Good, since I've got an x over here, I need to get rid of that, so I'm going to subtract it. That's good news, because y squared minus y squared goes away on both sides. So we've
Now you
got...
gotta divide by negative.
The last step would be to divide by negative 12. So y will equal negative 1/12 y squared.
Yes.
Try to write that neater. There we go. X squared. It's x squared. X squared. That's it.
I know, well, this really ain't that hard. It's just like
It's just several steps, that's all. Okay, now what we did on those two problems, we were given a focus and a directrix, and we wrote the equation for the parabola. Those notes that you copied down off the picture, you're given the equation for the parabola, and you got to find the focus or the directrix. So it's going a little bit backwards. So that's what we're fixing to try now. Okay? Everybody got what you need on that?
I have a question.
Yes, ma'am.
So if you get goosebumps and your hair grows because you get goosebumps, why isn't my hair on my arm really long?
I don't know.
Like, that doesn't make any sense. I always think about that. Like, 'cause every time I get cold, I'm like, oh my God.
Okay, here we've got an equation. Negative 4x equals y squared. The directions say identify the focus, the directrix, and the axis of symmetry. Okay, so the previous problems that we worked, we were given the focus and the directrix, and we wrote the equation. So this is backwards. This is going to come off the notes you took a picture off of. Okay, so that's what I'm going to be referring to. First thing I'm going to do with this equation is try to rewrite it so that the variable to the first power is solved for. So my variable to the first power, this is x. It's being multiplied by -4, so I'm going to divide by -4. Very good. So we're going to divide both sides by -4. So that's going to give me x equals, and if I'm looking at those notes, it's all written in terms of fourths like that. So I'm going to write that as -1/4 y squared. Okay, so now I want you, on your notes that you took off the picture, I want you to tell me, am I on the vertical section of it, or am I on the horizontal section of it?
Horizontal.
Good, horizontal, because horizontal says x equals. Okay, so everybody's looking down at that bottom half, right? Now, am I on the p greater than 0 or the p less than 0? Less, because I've got a -1/4, right? So everybody see where we're looking at, okay? Now it tells me that out of this equation, my focus is going to be P0. You wrote that down. So if it started with started with 1/4 py squared, 1/4 py squared, what would my p have to be to get this? Okay, I know, crazy sounding question. Check this out. The 1's the same, the 4's the same, the y squareds are the same. What's different is this one has a negative and this one does not. So what could p be that would make this be a negative? 1/4 times what would turn this to -1/4?
1/4 times
-1. Very good. Okay, so in this case, we would say that our p is -1. So you now know your focus. Focus is -1, 0. Okay, now you wrote down on that the directrix is the equation x equals -p. Well, our p is -1, so our directrix would be the opposite of -1. It would be good. Everybody okay? Alright, axis of symmetry on this. You should notice that the graph of this thing, you're looking at the one that looks like that, right? Okay, so if I found -1, 0 for my focus, if that's -1, 0, and if 1 is my directrix, there's my directrix, I've got to find what that vertex there would be. Any thoughts on how we could do that? Say that again.
Obviously, there's -1/5. It's half of
Yeah, -0.5 is half of 1, but that's good. Stephen's thinking real good, and my picture may not be drawn real good. I want you to see this, Landon. If the vertex is halfway between them, like Stephen's thinking, that's at -1 and that's at 1. So where would the vertex, what's halfway between -1 and 1? 0. So I drew my picture screw. That really should be, and what's that called?
the origin.
The origin, what else?
That y-axis.
It's, yeah, that's close. The axis of symmetry is what cuts that parabola in half. So which axis is it that's cutting that vertex and the parabola in half? X-axis, right? So my axis of symmetry is the x-axis, or that's also known as y equals 0. Either one of those would be acceptable. Okay, I'm going to try one a little bit, step it up a little bit where our p's, we got to do some figuring to find our p. That one, the p was kind of obvious because the only thing that was different was the negative. So here we go. Everybody got what you need there? we got negative 2x equals y squared. So same stuff, focus, directrix, and axis of symmetry. Alright, so first thing on these is to make sure we're in standard form. Standard form will be the variable that's to the first power is solved for. What do we do to solve for our variable to the first power on this one? Good, Trevor. So that's going to give me x equals negative 1/2 y squared. Alright, so x equals means that I'm looking at the horizontal stuff again, right? Normally, it is the normal equation that you wrote says x equals 1/4 p y squared. Okay, I've got a negative 1/2. So what would I do to 1/4 to make it be negative 1/2?
You divide by decimal.
Yeah?
What decimal?
I don't know. Say that again, Stephen. Oh, I thought you already said it. My bad.
Point
I
five.
said divided by
No.
Okay.
Wait, yeah, point five.
Dividing by 2 is the same as multiplying by half, so that's good. Y'all are all right on that. So this, if I took negative 1, listen, hoodlums, if I took 1/4 and I multiplied it by negative 1/2, it would be here, right? Is that what y'all are telling me? Okay, so our P is, so not right, Chloe, you just shook your head at me. Okay, I'm sorry. I apologize. I'll try not to let it happen again. It means our P is a negative 0.5 or negative 1/2, whichever way you want to write it. That's the hardest part. Because now your focus is just P0. So up here for my focus, I've got negative 0.50. My directrix is negative P. So my directrix is x equals 0.5. Okay? Now, this is the same type of parabola as the last one that we saw. Since it's x equals, and since it's a negative, it opens to the left, right? It's a sideways one. Axis of symmetry, unless these things are scooted on, that's called a horizontal parabola. Unless these things are scooted on a horizontal parabola, the axis of symmetry is going to always be that. So our axis of symmetry, again, is the x-axis, or if you prefer, y equals 0. So when on a sideways parabola, what would a sideways parabola look like that's not the axis of symmetry on? What would the equation look like where that's not the axis of symmetry? That's still one of these. And wouldn't it have to be like not centered there? So we'd have to have a plus or a minus something stuck out on the end of this, right? And we're not even there yet. So for right now, that's what they'll be. What would the axis of symmetry be if the parabola was like the top half of your notes? If it was like that? Y-axis, very good. Or you could say x equals 0. Very good, Chris, one on that. All right. Good stuff there. A little bit confusing because it's new, but it's not, if you got those notes on what to pull from, it's not very difficult.
Are you going to let us use our notes?
Probably.
We did 3 problems in almost 50 minutes.
Yeah, that's insane.
Those hard ones.
That's insane. We're fixing to do one more.
Oh, not one more.
Alright, I've got a directrix that says y equals 3. And I've got a vertex, I haven't done that to you yet, that's 0, 0. Okay? Alright, so looking on your chart there, my directrix says y equals, am I in the upper half or the lower half? Upper, good. So my directrix is y equals 3. What does that mean my P is? Negative 3, good. So my focus would be? on the top part, didn't it go 0 first?
Yeah, so zero and everything.
So there's our focus. So we've got a focus, we've got a directrix, we've got a vertex. What else does it ask us for? We're trying to write the equation. Okay, well, the axis of symmetry would be 0 there because of the vertex. We're trying to write the equation. So look in there in that top part. It says it starts off as y equals 1/4 p x squared. You know your p, we found that. So that's going to be y equals 1/4 times -3. That's it. That's your equation.
That's your answer.
That's my kind of problem there. That's a little bit easier. Now, if I did not have those good notes and I might forget that it's 1/4 p, I might struggle a little bit, but you've got those good notes and you remember that. Most of the multiple choice tests, like ACT, they'll put that negative just out in front. Go write it that way.
I got a question.
Yes.
What we did first, what did that have to do with that?
We went. It's
That
all,
right there,
yeah,
to that.
that they already gave us the directives and the focus.
Alright.
So we
All we had to do was
Right.
a few steps.
Right.
All we had was a couple things.
Yes, we didn't have us all the same stuff yet, yes.
Why the hallway light was 20?
There's
Nobody's in it.
nobody's in it.
Motion's in the Trevor.
Same.
Maybe if you were smart,
You can play it from the wall.
but you can't.